Hello everyone, myself SAIKAT MAITY, student of MTech Photonics in Department of Physics, IIT Roorkee. This PPT is submitted to Professor Mayank Goswami under the course Computational Technique and Programming. My video PPT presentation topic is Monte Carlo integration using MATLAB. Now I would like to give you an overview of the presentation. So firstly, introduction. Then why we need to use Monte Carlo integration. Then I will give an example. After that I trying to solve an integral. Then I will discuss the approach to solve the integral. Then I will move on to the pseudocode for integration. After that I will discuss the MATLAB code for integration, then the results. So first I would like to give you a bit of background. So Monte Carlo integration is named from the Monte Carlo casino in Monaco, famous for gambling games which is based on random outcomes and cannot be predicted. Monte Carlo method is invented by John von Neumann and Stanislaw Ulam to produce atomic bomb during World War II. They used the gambling game concept of randomness. Uh, Now I want to discuss the why and how Monte Carlo method for integration is used. Monte Carlo integration is a numerical method for estimating definite integral. It uses where analytical method may be impractical. Here we can see that for this integral, we can see that for this integral, the graph is too much oscillatory. So here we cannot use the Simpson one-third rule and trapezoidal rule. In Simpson one-third rule and trapezoidal rule, the function should be smooth or well behaved. So to estimate this integral, we use the random sampling. If we change the if we increase or decrease the number of random samples, then the value of the integral will be changed. The value of the integral will be changed. Now here we can see that an example, the original value of the pi is 3.1415. Now if we change the number of random samples in this graph, then the value of the pi is changed frequently. Now I would try to solve an integral integration 0 to 10 x squared dx, which is simply area under the curve. Can we estimate this integral using Monte Carlo method? So using Monte Carlo method, we cannot create the exact solution of this area, but get a decent solution. If we increase the number of random sample in the graph, we can get it. So then the approach we use to solve this integral is, suppose we throw many number of spherical marbles to the 2D wall, then there is a probability that some of them will stuck above the curve and some of them will stuck below the curve. Then but we are interested in the mud ball which is stuck below the curve, which will give the area under the curve, that is the value of the integral. So now we move into the MATLAB to show how we can calculate the integral. Before going to the MATLAB, we see the pseudocode for integration. Firstly, we define the function to be integrated, then we define the integration bound, then we taking the n number of random points, then we calculate the exact value of the integral using MATLAB inbuilt function. Now generate the generate the random points within the integration bound. Then we evaluate the function at these random points. Then we calculate the average value of the function. This is the estimate value of the integral value. Then we calculate the percentage of error from the exact value of the integral. Now this is the code for MATLAB. This is the MATLAB code for integration. First of all, we define the function to be integrated. F equals to @ x, x dot to the power 2 Mm, here at the rate x is used to define the integral, to define the function x square. Now the lower bound of the integration is a equals to 0. The upper bound of the integration is b equals to 0. The number of random samples used is 10,000. Now calculating the exact value of the integral using the MATLAB inbuilt function. The SYMSX means the one dimension x is used. If we have to calculate the xy three-dimensional integration, then we use the SYMS XYZ. Here only one variable x is used, so SYMS x is defined. So the exact value of the integral is the exact value of the integral is calculated by the MATLAB inbuilt function y int of yab, where y is the function, is the lower limit of the integration, b is the upper limit of the integration. Now the fprintf function is used to print the exact integral. Now we generate the random points within the integration bound using the rand function within the integration bound a to b. Uh, Within these bounds, the random points are x equals to a plus b minus a into rand of n comma a1. Then we evaluate the function at these random points within the bound a to b. That is y random equals to f of x. Now we calculate the average value of the function, that is the b minus a star mean of y random. That is, we calculate we estimate the average value of the integral. This is our estimated integral. Now display the display the estimated integral value using a printf function. Now we calculate the percentage of error from the exact value by absolute value of exact integral minus integral estimate by exact integral into 100. Now we display the error in percent from the display the error in percent by a printf function. So here you can see that the in command window the exact integral is 333.33 and the estimated integral is 332.201 and the percentage error is 0.33%. So now we see that for n equals to 10,000 random points, the exact value is 333.33 and the estimated integral is 332.201 and the error in estimation is 0.33%. So thank you for the attention.